Good morning. Myself Santosh Kumar, professor in SR University, Mechanical Engineering Department. So previously I have an experience in 5 years in industry, mechanical engineering based. So during 20 years back and 10 years back, we have seen a decline in jobs in especially in the package wise in mechanical engineering. So and this was still more increased during pandemic stage. The reason behind is that most of the industries required physical involvement. Especially this was got negative towards in many core branches and even pharma and fashion industries. So, so from there, most of the packages are reduced for mechanical engineers, especially. So because the employees not able to visit, physical intervention is completely got stopped during pandemic. So from there, we can see the decline of packages, and most of the companies started to take advantage of that. So, but however, another side, academia started to improve this drawback to regain its most of the students, B.Tech students get good placement with compared with other circuit branches and especially with CSE background thing, because that's how they are getting good packages. And during pandemic stage also they got huge package because they can access the internet, and by using in the system they have got high packages. Even some of the people have made two jobs in the regular basis, like morning and night. This is the situation we can see last 2 years. So however, most of the companies started to initiate to bring this fact all the employees to the from work from home, and they stopped and they brought to the companies. So from there, we can see how this can be improved for the any mechanical engineering packages. Any graduate can get as compared with CSE people, means computer science branches. So that's how the IITs and IIC and most of the foreign universities have started uh, to develop virtual reality courses like smart manufacturing, virtual augmented reality manufacturing, and so on. So in India, there are few colleges have started these courses. Like that course started with the name smart manufacturing. But why we need to learn this course? What is the need? As I told this, due to COVID situation, that most of the factories like physical intervention required with man to machine, it is almost stopped, and 48 crores of rupees got lost in, and this was declared by some of the best top newspapers in India and abroad as well. You can see here suffered almost 150 billions of rupees economic loss during that time. And even another side, as I told, this IT sector is boomed like anything, for growing fast and fast in the decade, like 227 billions in during pandemic hit physical year like 2022. So somehow to as compete with this like IT industry, the another industry like core branches like MEG and Triple E and ECs faculties, or most of the employees lose their jobs due to there is no physical interaction with the people and machinery. So there is a option get started like bringing the new technologies like integration with AI and automation, and that can be helped in the future as well if any issues comes like pandemic. There they have started to understand uh, integration with automation and by using even the person or engineer sitting in home, they can run the machine uh, to not to stop the production. So these are the some of the job roles newly established in for mechanical engineering. So as we see that initially there are only graduate engineer trainee is a traditional uh, jobs for Indians. Sorry, not any engineers like enter into any initial stage like they get graduate engineer trainee, then PGET, then there are some other roles like then you become senior engineer, then assistant manager, then senior manager, and then maybe a GM, then chief operating officer, chief operating officer, then maybe continental head, something like that. So this is a traditional way of uh, job development or career development. Any uh, core branches student, any one is joined in initial stage. This is the level of hierarchy, and they get jobs and salaries according to this. Okay, especially in India, like developing countries, graduate engineering training initially they get 25K per month, maybe maximum that 4 to 5 lakhs per annum. This is very very less, whereas compared with initial stages, with current scenario in the other side we can see CSE, these branches like initial package nowadays like 20 to 15 to 20 LPA and so on. So from compared to this 4 LPA to 15 to 20 LPA, this uh, what is dominating here? This is the technology and adaptability of companies. Those technology like AI and or ML or automation. So these technologies they have almost uh, they acquired like these kind of computer based companies, and there are lagging in adaptability of these technologies for mechanical. So this the problem is that most of the in curriculum based companies sorry uh, colleges have not yet started to adapt new technologies their curriculum. The outcome is that same old traditional engineers are coming to the market, and they are not able to cope up with advanced technologies like companies they are in implementing these uh, new technology, like we can take Siemens, ABB, and so many companies, GE, MWay. They almost 90 percentage of companies are automated, and they are able to shift into industry 4.0 jobs. But however you can see the most of the colleges needs to improve their uh, curriculum based upon the requirement of industry. Even any issue in future comes like pandemic, the companies has to sustain with by uh, only the advanced technology with that. So we can see that now the initially there are very less job names we can hear, that is design engineer or some maintenance engineer or production engineer. There are only very traditional 4 to 5 jobs available for mechanical or any triple E or ECE students, and they used to get very 4 to 5 lakhs package. But where you can see the advanced courses like job roles like smart mechatronics engineer, digital factory, digital process, and so on. Even this uh, uh, maintenance or production This comes under production, this comes under design and mechatronics, advanced mechatronics, and like it is integration of mechanical and CSE and ECE, like cyber security and all. It is also required. Then virtual augmented reality, this one, and then the smart manufacturing data analysis, dashboard software engineer. Then these are like completely related to the mechanical and CSE, and these are advanced jobs for design engineers. So the job roles and base everything is changed according to industry 4.0, and now the transition is happening to industry 4.0 to 5.0, where the robots has almost they are going to remove, and it is going cobots. Cobots is a advanced technology. Robots, like even a human can the robot can understand human, and we can change according to the need of requirement of any uh, processing or operation. Whereas in robots only the engineer can define the moment that robot can move, but it won't understand if any object will come in obstacle, it should not touch that. So this kind of understanding and capability having this kind of robots. So these are the some of the new roles as emerged as in mechanical engineering as compared to this old specialization, old job roles. Now it is a responsibility to engineer, like any graduate, apart from their traditional courses, the student has to learn these kind of advanced courses so that they can easily get the minimum the packages, like these are more than this, because you can see that the students coming out from CSC and other other branches, the number is high, getting huge and huge. When coming it's more, then obviously the this package will go down. Maybe I wish it won't reduce, but the quantity of student coming from the CSE, this may reduce, and it will take the advantage by industries. So but if you see in another perspective, the positivity, like getting coming out from colleges of from mechanical, this number is from the last 5 years it is very less. So where the now the if you learn this kind of courses, the demand is very high compared to this. I can say that if you expert in any of these 20, easily you will get with your proper academic background. If it is strong, then easily you will get 30 lakhs per annum, where I've seen most of the IIT students and triple IT students, even NIT and National Importance College, or even normal engineering colleges, they are getting huge packages because they are understanding the need of the industry, and they are learning these technologies and getting huge packages. So first we need to understand the current scenario, like where we are now. So we are in the transition of industry revolution 5.0. So before that we need to understand the 4.0 and 3 2 1. So in initial industrial revolution, like the industry started mainly concentrate of production of mechanical product, like movement of people and movement of things from one place to another place. That's how steam engine rails emerged. Then after that, the people started to do same things in mass way, like mass production quantity. They started to increase. So that's why most of the industries emerged, and the required electricity then they started to integration of electricity to the assembly lines in the factory. Then the production increased and the quantity also increased so much. Then the in industry 3.0, the computers has emerged to optimize this quantity and understand the things, uh, and to monitor everything from your where you are sitting. Then everything got helped by using internet and CNC and NC machines. So now the things is got still improved, and we can see the cyber physical system came into picture, where the factory is in somewhere where we can sit in and some another place where by using your uh, internet or cyber systems we can operate your physical system like factories and so on. Still we are moving towards industry 5.0, where still advancement in going to come into picture. So my suggestion is this young engineers, like, so most of the students are this level the syllabus which they are getting knowledge, but still they have to improve and learn these kind of industry 4.0 technologies as I shown in the previous slide, so that they are ready to work in this field or even this field. That's why the packages are here 30, and if you are really good in still further advancement technology, if you learn, the packages may go 50 to sometimes 70 lakh per annum. So most of the companies they are ready to invest this much packages in the students are ready to work in industry 5.0 technologies. Then we should understand first, before going to deep down into industry 4.0 or smart manufacturing technologies. First we should understand how the factory structure will be, then how it is going to converting to smart factory like this. So before that, first we should understand how the factory like that we can see people used to assemble the machines and automobiles initially with manually uh, in each and every part. So in current scenario, like, the robots are ready to replace and change and assemble everything in single assembly line, and by using this robots, and this is I industry 4.0 technologies. Smart manufacturing, briefly I can tell that smart manufacturing is a process that optimizes manufacturing procedures through automation, big data analytics, and computerized controls that minimizes cost and maximize productivity. Then what are the benefits of smart manufacturing? Smart manufacturing enables a continuous operation improvement, the increasing productivity, decreasing costs. Then self-monitoring and predictive maintenance is enabled by machine learning, reduces downtime and repair costs. And another advantage is real-time awareness of state of production, equipment and raw materials, make it easier to meet changing customer needs. So we'll spend some time here. We'll discuss more in benefits how this is uh, helping in current industry 4.0 technology in industry. So especially how it is going to help in any pandemic situations. Okay, so assume that there is a factory in New Delhi, and there is a manager sitting in maybe Chennai. Okay, so somewhere he traveled and he got announcement that going pandemic is going to start from tomorrow. He almost reached Chennai. So, but however, his intervention is required in industry, so that he has to verify physical changes in the systems, and he has to give commands everything from his maybe a system or laptop. But sometimes he has to verify that which he cannot do with only uh, by I can say video calls and so on. So during that stage, so the industry 4.0 technologies like digital twin, where the clone of this exact physical system can be made in his laptop or system, high configuration systems. The things, whatever physical system is there, he can have in this laptop, and whatever the changes is happening, he can sense, not by touching physically, but by touching the data which is getting from the sensor. Okay, so that's how your predictive maintenance will help. So in predictive maintenance, the sensor will sense the data, example emission, there is a bearing, okay, and you want to sense the bearing is the alignment is properly there or not, or any vibrations are coming, or what kind of vibrations are coming, and how it is drilling. Everything you can see by keeping one small sensor here and put it into a data acquisition system, and that will connect it to internet, and that internet connected to this employee. Now whatever the change is happening per second, he can sense by using this integration, and he can get this information easily in system. Then he can tell that not by not his physical presence, but the data which is coming from the sensor, he can get that information, and he can give the guidance to the factory. Even the sometimes factories allowed in during pandemic 1 or 2 people or engineers, so they can change some component, or even um, the robot can get the we can take the help of robots and for assembly and disassembly of that. So also not only by changing, but also sometimes we can allow some other more time to run the bearing, so that we can avoid to replace again and again. We can do that by verifying the predictive maintenance when the bearing going to failure sometimes. So in and during running of the bearings, due to assume that the bearing life is some maybe 6,000 hours. Okay, during this 6,000 hours, with normal condition, maybe in after 1,000 hour, some abnormal condition, due to that there is a high peak is coming. So it is predictive maintenance will help that. Here it will analyze the peak from the abnormal peak before, um, is that kind of abnormality is there or not. It will observe, and it will tell that it is not failure. We can understand from this, it is not a failure, it is some situation where we can leave for this abnormality, but we can see overall bearing vibration by using your statistical parameter, and we can allow it to run for 6,000 hours, so that we can save 1 or 2 bearing cost here. Okay, that everything will be helping through your predictive maintenance. Okay, so another side, we have this real-time awareness, the state of production equipment. As I told, there are many departments, and there is interconnectivity is there with your internet, and the person sitting in somewhere, he has to verify the each production facility, and what is the productivity, and what is the maintenance, what is the issues arising in the machine, everything he has to maintain as a maintenance engineer during initial stage. The person has to stand or near, he has to stay here like 24 hours. He has to see the changes, and he has to note down in logbook any abnormality is there. Then he has to inform to management, then they will take action. So it is very time taking process. So the sensors are helping maintenance engineering by your condition monitoring techniques, so that he can sit in somewhere and he can understand the abnormality, and he can immediately stop if any issues are going on. So that's how he or she can see the real time um, systems, and you can get aware from not to stopping from the production. So you can see the following these steps: introduction to smart manufacturing. This any student can learn, and the hierarchy I'm explaining how we can imbibe into these technologies. Then foundations of industry 4.0 by integrating IIoT technologies like cyber physical system. And then you can go for digital twins and advanced automation, where we can do our replication of your physical system to virtual systems, then integrate that system to AI, so that any machine learning and AI algorithm is required for prediction of some failures we can do from here. Then finally we can integrate those technologies to any manufacturing factory, so that everything cyber security is required, because most of the companies are now this connecting to one another in internet. So it may attack any cyber attacks to those physical systems. So cyber security is very very important in current field. Then what is industry 4.0? Industry 4.0, which is a synonyms of smart manufacturing, the realization of digital transformation to the field, delivering real-time decision making, enhance productivity and flexibility, and agility to revolutionize the way companies manufacture, improve, and distribute the products. So Industry 4.0 has given the rise and emerging sector in manufacturing. So that's we calling as smart manufacturing, and that opens door for analytical in the industry. It is a technology driven approach that utilizes the IoT and internet connected devices to produce goods and monitor processes. The goal is to automate the process involved in manufacturing to maximize efficiency and increase sustainability and supply chain management. And it also identifies the system like barriers even before they occur, any generating, optimizing, and implementing enormous volumes of data. So these are the core technologies in industry 4.0 which help uh, to develop any normal factory into industry 4.0 technologies. So the pillars like your big data analytics, autonomous robots, the simulation, horizontal vertical system integration, IoT, cyber security, and the cloud active augmented reality. So generally, if you see the any system, as explained in the previous slide, we required sensor to get the sense of that particular issue and get the information to the particular engineer or manager or operator. So it is the data is coming day to day, like it is huge, terabytes. So we call that the big data. So how to manage that big data and how to analyze that data into in the small form of like dashboards, that is very important. And autonomous robot, like you can see, sometimes the physical intervention is not required. So during that time the autonomous robots will help, that we are now calling that cobots. So the cobots will go to those particular places where a human cannot enter, especially in steel wire extruding manufacturings, and having more than 1000 degrees centigrade, where a human cannot enter. During that time, even the robots or cobots are helping in that kind of situation. And even sometimes during integration there is a requirement of cyber security from one factory to another factory. And even because getting attacks from other, maybe a competitor, is obvious. Okay, so now this everything into added into cyber security. So without security of this internet to factory, it is very difficult. So during this kind of situation, your IIoTs devices are helping a lot, including your Zigbee kind of IoT devices rather than using a normal security devices. But yes, the data is coming to sometimes it required the cloud, because we have to travel from one place to another place. By sitting in factory, it is not able to uh, not not advisable to some engineers, so that they will has to move one place from another place. So that cloud is helping the to do their own jobs, like the any maintenance engineer traveling from one another place, he want to monitor what is happening in the factory, like the particular machine. So you can see the information coming to the uh, system. Then system is sending the information to the cloud and it is storing there. Then you want to see the uh, whatever the things happened in yesterday, you can analyze by using these cloud storages and all. Another side, the technology like additive manufacturing, it is helping a lot, because as you can understand, the traditional manufacturing like casting and fabrication machining required a huge amount of lead time, because this to especially when you consider any casting product, it required a minimum, if it is large, uh, 1 meter diameter component, if you want to manufacture minimum, any supplier, they take 60 days to 70 days time lead time to fabricate. Yeah, they have to do the casting, then they have to do machining. Then if they found any blowholes or pinholes, we called as cavities, these kind of things, then they have to, company they won't allow to uh, do assemble the product. During that stage they have to reject, and again they have to start a new machining of that particular, including casting. Again they required 50 days minimum time. So to avoid all those things and delays, so additive manufacturing helping a lot, like 3D printing of components, where we can avoid these kind of rejections, and we are minimizing that 60 days time to at least 10 days time if it is more diameter, like 1 meter and all. Yes, obviously there is a cost involved in additive manufacturing, like the some X company, they want to manufacture a component with 1 meter dia, like they cost uh, max they will charge around 30,000, that is including a pattern cost and machining and final delivery. But whereas in additive manufacturing and 3D printing kind of technologies, like we called as selective laser sintering printers, SLS machines, uh, required huge investment, like in lakhs crores of rupees. Obviously this it is high investment, and still this people are developing to reduce technology, to reduce the cost by developing some other technologies for especially metal 3D printings, so that companies can take advantage of that by minimizing the lead times. Another side, you have augmented reality and virtual realities. So this is very very important when we moving to industry 4.0 to 4 5.0 transformation, industrial transformation, especially when an engineer is traveling from one place to another place, and somewhere he has to give physical uh, help, like intervention is needed. So during that stage he has to verify in part by part by zooming. uh, it is very difficult in normal video camera calls and all. So that's how augmented reality and VR came into picture, where the physic the where the exact replica of the machine can be designed, and it can be sent to a uh, like technologies like by in design like Unity and Vuforia, they where we can send a small QR code to the people like engineers. They can scan it with their mobiles, and they can open and zoom. They can give observe the problems in the machine or part, and we can give justification or rejection by with the proper manner. This is the this is how these nine pillars are helping for industry 4.0. That's why this initial stage I shown, there are 20 different jobs is related to these nine pillars. You can see the cyber security and all comes in this here, the related jobs, and CSC and mechanical integration jobs, and additive and augmented reality jobs, and you can digital twin and simulations lab jobs, and robots related jobs. Many things, everything is emerged from these nine pillars. Then what are the impacts of industry 4.0 on manufacturing process? It involves the digitalization of manufacturing process by collecting, analyzing the data from every stage of production process to optimize manufacturing process, reduce waste, and improve quality. It uses cyber physical system to create network capable of real-time monitoring and control big data analytics. It also identify patterns and trends to enhance efficiency and reduce downtime. Industry 4.0 also involves advanced robotics and automation to increase productivity, improve safety, and reduce cost. Then when industry 4.0 implement in the automation coming to picture, then these are the some roles enhancing efficiency across various sectors. We can increase the productivity, we can reduce cost, and consistently we can verify the quality, and we can maintain same consistency almost. Then speed up the process and time efficiency and data integration and data management we can do. Because all the data, authentic data is coming from the sensor. We can verify and we can analysis. The safety and risk management also can be improved by taking proper measurement from cyber security integration. Scalability, we can improve the increasing the production uh, plants or quantity we can increase. Because example, the company currently if they have only two plants, and there are only lesser management employees are need to verify continuously in two places, and means the physical intervention is required to manage two factories. If this in the 4.0 comes into picture, the management they can um, do monitor by sitting in one room, and they can verify and understand, and they can increase the scalability by developing more factories and enhance customer experience, because the most of the customer, they want to understand whether the order is execution happening or not, and what kind of uh, what is the stage of this the customer order uh, is there, and is there any issue is coming, and they are the supplier is or factory people are not informing to the customer. So these kind of doubts generally will arise when any customer gave the orders to any factory. So these kind of delays and issues can be resolved, because the transparency there, the factory can send a small link to the customer, so that he can see the in the dashboard where the issues are coming, how the factory is resolving, and how the production is going. So everything can be once seen by the customer, so that he can enhance the customer experience will be improved like this. Then resource optimization also can be done, and innovation and competitiveness and advantage is there. So one of the case study we have seen in recent days, in that is Amazon robotics in warehouse, where they have implemented for the e-commerce and warehousing, the management, the challenges what they are facing, like managing a massive inventory and ensuring timely order fulfillment in a high demand e-commerce environment. So the solution, they've started to understand how we can resolve these kind of issues. Then they've started to adopt the Kiva robots. Kiva is a manufacturing company of particular robots. So they have implemented Kiva robots in fulfillment centers to automate picking and packing process. So the robots bring shelves to products to human workers, who then pick the items for packing. So from this, the company improved the efficiency of 300 percentage, and efficiency gains like reduced their time taken for locate, pick and place items, and minimize downtime. The cost saving, significant reduction in labor cost, and improved space utilization of warehouse. Another companies like Tesla, they have used, and some of the even researchers also started to adopt these technologies, IoT technologies, so that they can even they can sit and they can understand what is happening. They can do research and abnormality of some parts, and they can analyze, and they can publish the papers, and so on. And even the FMCG companies like McDonald's, they have used like mobile robots, like for food industry. The challenge is like improving order accuracy and speed in a fast paced environment. They have used self service kiosks and mobile ordering system in restaurants, so where the robot, this kiosk will go collect this package of particular food item, and it can go to that particular delivery place, and it will deliver the package and in time. So that the results of from this, observe that the productivity increased with faster order processing and reduced wait times for customers, and the improved accuracy like huge, and customer experience like enhanced customer satisfaction through efficient and personalized services. These are the some success stories, and through smart manufacturing process, where we can understand the requirement of current uh, roles, if any graduate can learn. So these technologies, how he can benefit from out of that. And obviously the person easily can uh, easily get more than 20 or 40 LPA per annum. Okay, with this I'm concluding, and all the best for your careers. Okay, thank you.